So what is the problem with the risk neutral pricing? It works well most of the time, but for interest rate model, it creates some problems, some inconvenient problems. We introduced the black formula to price caps, floors, and swaption. You can regard this one just as a Black-Scholes formula. We can cover this one later. In this section, we review risk methodology that provides no arbitrage underpinning of this formula, which is particularly convenient for the analysis of fixed income securities. The methodology is called forward risk neutral pricing, and it is at the basis of live market model. Live market model is the most popular model for interest rate and fixed income securities. Brace, Gatrek, Musiala. We also review His Zero Merton. Actually, we already covered HJM model. I think it was last week's framework, whose path breaking logic led the way to the current approach to fixed income security pricing. So basically, this live market model, we can regard this as a special case of HJM model. And actually, every interest rate model is the special case of HJM model. Let's consider an interest rate model. DR equal, we have drift term, and SDX. DX is the Brownian motion. DX follows normal distribution with mean zero and standard deviation, no, variance dt. By no arbitrary, the price of fixed income security with pay of GT at T must satisfy the fundamental pricing equation. We learn fundamental partial differential equation, also called the fundamental pricing equation, FPE, looks like this. So intuitively, you know, this left hand side is return from the return. If you put the V is the current value of fixed income security or any asset, V is current value of asset. So you can regard this left hand side as the return if you put V amount of money in the bank. On the other hand, right hand side is like expected value, which is from Ito formula, expected value. If you invest in bond, change in time. So this is function of time and interest rate. So first part is a change because of time, second part is change because of the interest rate. But since it is the stochastic process, we have to take into account second moment. So we have this term. So basically it is Ito lemma, and we drive this one. I hope you remember this one. So it is fundamental PD. So boundary condition is this one. Okay, at the maturity. So this is condition at the maturity when small t is big T, and then if we solve this one, and then we can get the price of this one. This is very important result we learned like 2 weeks ago, I guess. Any question? So it is a brief review of what we learned. Any question? You should understand this one before we proceed to the next part. Is it okay? 김영삼, is it okay? EQ, it is okay? Yeah, let's continue. Now, we know the solution of this one. As we can recall, we can assume we live in a risk neutral world, and in the risk neutral world, we can simply discount the terminal value with risk-free rate and the expectation of it. In one difficulty is that in the previous part, interest rate was fixed, so it is in the outside, so we simply discount it. But in this model, interest rate is stochastic, so we cannot put this one in the outside. So this one creates a inconvenience. Okay, but I mean solution is the same. We are assuming that we are in the risk neutral world. We get the terminal value and discount it, right? And then we can get the expectation of it. Only difference is that this is now stochastic, so it is inside of the expectation. Okay, so this is the solution. 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 So the only problem. Where the expectation E star, so we have E star because we want note take that we are in the risk neutral world. Where the expectation E star is taken with respect to probability distribution implied by the risk neutral process. So we have to think about M star. Okay. So in the risk neutral world, interest rate should follow different process. So we have to distinguish this one. So this is the interest rate process in real world, and this is the interest rate process in the hypothetical risk neutral world. Okay. So actually we can. So in reality, we know the data for this one. We have data, some basic securities. We have market price for this one, so we observe this one. So from this one, we can recover this one. So we can estimate interest rate process in the risk neutral world. That's the basic idea. But anyway, the major difficulty in computing this expectation stems from the fact that the interest rates are entered twice in the formula. This is inside of this expectation. First in the discount term, this one. And second is the final. Possibly, if GT is GT is a function of interest rate at terminal rate. So it is possibly the function of interest rate. Okay. Therefore, if current interest rate change, then we can expect the future interest rate change. Then therefore GT would change. So interest rate, the stochastic interest rate, can affect this one and this one. So this is inconvenience. So it means this one and this one are correlated with each other because they are driven by the same interest rate. For instance, if we are pricing a put option with maturity T note and strike price K on a zero coupon bond, so it is a put option, but underlying it is bond, not stock. But formula is the same. They will exercise put option only when the bond price is less than strike price. So terminal price is same. But zero coupon bond itself, this one, is the function of interest rate. If interest rate go up, this go down. This interest go down, this go up. And this terminal interest rate should be correlated with the current interest rate. And this current interest rate also affects this discount rate. So this creates a correlation between this and this. Computing this expectation is then hard, as we need to take into account the natural correlation that exists between the discount and payout. Question about this page. The key idea is that this one and this one is correlated. Question? No? 남정식, any question? Which one? You mean this one? You cannot understand this one? You cannot understand this one. Also, you cannot understand why there is a correlation between the two. 이해할 수 없다는 거예요. 이해할 수 있으면 yes잖아. 영어로를 부정문으로 물어보나 긍정문으로 물어보나 yes로 대답해야 되는 거 아니야. 이해할 수 있으면. 이해할 수 있으면 yes. 그러니까 부정문으로 물어보나 긍정문으로 물어보나 영어는 똑같아. 네? 헷갈리면 안 돼. 우리말하고 달라. 그래서 질문 있어? 오케이. 그걸 짚고 솔루션은 이렇게 생겨야 된다는 것도 알지. 박남도 질문 있나? 쉽지 여기까지는? Indeed, the covariance formula, okay, covariance between zy, we can decompose into e zy, e z, e y, where z and y are any two random variables. This implies that we can write this SF price, which is this one, as this one. Okay? So this covariance part is inconvenient. We hate this part. Okay? If we could eliminate the covariance term in this expression, this one, computing the expected value of each individual term, this one and this one, is much easier. We can calculate them separately and plug in and we get the answer. But because of this one, we have to calculate correlation. Moreover, we already know this one. Actually, we don't have to get the value of this one because we already know this one. This one is simply zero coupon bond price, right? You can assume that you can multiply 1 over here, then it is the price of $1, the price of contract that pays $1 at time big T, right? Discounted value of $1. So it is simply zero coupon bond price. So we already know this one. So if we can separate this one into like this one, and if there is no this one, we can calculate only this one. That would be much more convenient. So effectively, we would be left to value the second one and only this one, if we can get rid of this one, because we know this one and this one zero coupon bond price. How we can do that? We need another inception. Okay. So in the movie Inception, we go to another one's dream, and in that movie, they went to another one's dream, right? Dream inside of dream, something like that. So which means that we have to do another inception. We have to change our numerator technique for the risk neutral dynamic. So in order to get the derivative prices, we have to go into the risk neutral world. Now, in case of interest rate model, because of correlation, we have to go to another inception. So not only risk neutral world, now we have to go into for the risk neutral world. That's another different world, another hypothetical